Okay, in our last video we stopped with how to create a cladogram, so I'm going to pick up there in this video. But before I do that, let's actually revisit that previous slide because I neglected to talk about why we have this change in classification. Again, this is based on molecular data, so if you look at the before cladogram, you'll notice that segmented worms and arthropods were clustered close together, sharing a recent common ancestor. That was due to just observing the fact that they're both segmented, and that's a pretty fundamental trait in organisms, and so scientists thought that they were probably closely related. However, after examining DNA evidence, we now have what you see over here to the right, the after cladogram. Turns out that arthropods are actually more closely related to roundworms, and we can tell that because of the similarities in their DNA sequences. So remember, some similarities can arise through convergent evolution, where two different organisms start to look more similar to each other, so sometimes it's a little misleading to use a physical trait to organize and classify life. Okay, so we're going to go back to the creation of a cladogram. You have a place to write this in your Power Notes, so don't forget your Power Notes sheet. Looks like this. We are now down here at the bottom of the page. And you have a place to write out the steps, which I'm not going to rewrite for you because I'm sure you can all do that on your own. And then there's a place to fill in this chart at the bottom. Whenever you're creating your own cladogram, I recommend drawing out a chart like this just to keep track of all of your derived traits, which are listed here, and the different groups of organisms are listed across the top. So you can really easily just put a check mark in the corresponding box if that organism has a trait or not. So I actually have this already animated in the PowerPoint, so we're going to return to the PowerPoint and take a look at that. If you are unfamiliar with what any of these organisms are, here are some pictures. The one that you may not know about is this first one here, the lamprey. That's a common question that I get. A lamprey is a long, kind of eel-like fish, but it's very primitive. If you look at its mouth, this is what the mouth looks like here. Right? A little freaky. It's just a circular mouth. There is no hinged jaw, meaning all it can do is suck on things. And so that's what it does. It uses these teeth to drill into the side of a fish, and then it sucks the blood of the fish. That is a parasite there, the lamprey. The other organisms you probably know about, turtles, salamanders, tuna, and leopards, are all fairly familiar to us. So here's your chart that you have on the sheet. Let's go through this together, thinking about the tuna, the leopard, lamprey, turtle, and salamander, and whether or not they have each of these traits. So we're going to start with the tuna. And if we think about the tuna, the only two traits that it has are the vertebral column and the jaws. It doesn't have legs. It doesn't have an amniotic egg, it doesn't have hair, so it really only has those two check marks. And while we're here, in case you don't remember what an amniotic egg is, this is the egg. It was discussed in Walking with Monsters how the organisms who laid their eggs on land had to have protective membranes to prevent them from drying out. That's what the amniotic membrane is. So anything that lays its eggs on land is going to have an amniotic egg, but even something like mammals, even though our eggs are internal, we don't actually lay those eggs. The membranes are still there, even in a mammal egg. So if we go through leopard, obviously it has legs. It's a mammal, so as we just mentioned, it does have that amniotic egg. It has hair, it has a backbone, and it certainly has jaws. So the leopard has all of these traits. Let's go through lamprey. No legs, egg, hair, does have a spine, but it does not have jaws. So lamprey only has one of our traits. The turtle, it does have legs. It can lay its eggs on land, so it does have an amniotic egg. No hair, but it does have a backbone and it does have jaws. It can open and close its mouth. And finally, the salamander, which is our amphibian, does have legs. As an amphibian, it has to lay its eggs in the water, so no amniotic egg here. No hair, does have a backbone, and it does have jaws. So now that we have our check marks in the correct place, we can start to place things on the cladogram itself. So as you look, the very first thing we're going to place on our cladogram is the lamprey. Now, how did I know it goes there? Well, it only has one out of all of these traits. So anything that only has one trait means it has to branch off closest to the bottom before those other traits come about. So that means the one trait, if we were to put our hash mark for the trait on the cladogram, the trait of vertebral column goes at the very bottom. That would be our ancestral trait for this cladogram because it was present in the ancestor of every single organism that we're placing on the cladogram. All right, next up, we're going to move the tuna into position. The tuna has two traits. In addition to the vertebral column, it also has jaws. So that means we're going to add jaws here as our new derived trait. Remember, all of the new traits that appear are going to be derived traits, and only that vertebral column or the spine was the ancestral trait that all of these organisms share. Our next organism is going to be the salamander. The salamander has 3 traits from our chart, so that means we're going to add the 4 walking legs. Next, we're going to place our turtle. The turtle has the new derived trait of an amniotic egg, so that means amniotic eggs are present from this point on in our cladogram. And finally, the leopard at the end. And there's one final derived trait of hair that we're going to place on our cladogram. So now you have a chance to practice this with the organisms from Walking with Monsters. So take a look at the other sheet I posted. So we're moving on from our power notes, and there is available to you this sheet. It's just for practice with Walking with Monsters, so you can fill this out. You can check whether or not the organisms have those traits, and then you can fill them in on the cladogram. So if you have not yet done this, go ahead and pause the video right now, see if you can figure it out, and then unpause it and you can come back to check your work. Okay, so hopefully you have a completed cladogram at this point. So let's go through our organisms and our derived traits here and see what we have. So we're going to start with arthropods. Arthropods had eyes and an exoskeleton, and that's pretty much it. They don't really have a hinged jaw. They do have some moving mouth parts, but they don't have a bone that's hinged on a skull like we would typically think of. They do not have that amniotic membrane. They don't have complex lungs. They do have a simple version of lungs, but it does specify complex here. They don't have bones, which means they don't have a backbone. They don't have the sail, and they don't even have skin. They use their exoskeleton as protection. So next we're going to look at fish. Fish had eyes and a hinged jaw, a backbone, and when we're talking about waterproof or scaly skin, we're actually not talking about fish scales. We're talking about like a reptile skin that feels scaly, but it's not made out of little flakes of bone like a fish scale is. So that's going to complete our fish row. Now if we look at the mammal-like reptiles, we're going to see that they have a lot of these traits as we go through. So they have every single trait except the exoskeleton. Reptiles, again, as we go through, they're going to have a lot of these traits. They don't have that sail, right? That was just for the mammal-like reptiles, so we're going to skip that one. But as reptiles, they do have that waterproof skin. So finally, amphibians. As we look at the amphibians, they are lacking 2 key traits of the amniotic membrane and that waterproof skin. That's really what defines amphibians as being different from reptiles. Reptiles can live on land because they have that waterproof skin. They won't dry out. Amphibians have to stay near water because they will dry out if they don't have access to that water to keep their skin moist. So now let's see if you got the cladogram correct. So we have, let's just go ahead and put it all out. We have actual pictures of the organisms from Walking with Monsters here. So the very first organism you see up here at the top, those are going to be the arthropods. They had eyes. They were the only ones with an exoskeleton, so if you put the exoskeleton on this branch, good job with that. That's exactly where it should go. Next we have our fish. Fish have the derived trait of jaws and backbone. So do all of these other organisms here, right? So we put it here, and everything from this point on has jaws and a backbone. Okay, next we have amphibians. Our new traits were limbs and lungs, and notice how I just wrote them both here together. If you put two hash marks side by side, that's fine. You can really show it either way. Okay, next we have eggshells, which is that amniotic membrane, and scaly skin that's present in the reptiles, which are going to branch off next. And our final branch is the mammal-like reptiles that have that sail. And the sail for temperature regulation is what makes these guys mammal-like, because mammals, being warm-blooded, can regulate their temperature. So that is it for the notes. Now, the other thing that I have posted is some practice. Okay? This cladogram practice is going to give you multiple opportunities to practice constructing and interpreting cladograms. There's a little bit of everything on here, from interpreting this table of traits. This is very similar to what we just did in the notes. So figure this out and then look and see which cladogram tends to match it the best. There's some multiple choice questions similar to what you might see on a quiz or a test. And then on the back, to really test and see if you understand it, we have a chart here that is giving you amino acid sequences. We have an outline of a cladogram. So see if you can figure out where these organisms would go on the cladogram based on their amino acid sequences. Okay, not giving away any answers to this at this point in the video, so go ahead and take a look at this worksheet here. Again, it's just called Cladogram Practice, and if you have questions, please shoot me an email.